Welcome to Dreamy Knowledge, and to our second episode, The Birth of Everything, the story of our universe to help you sleep. Drift into relaxation while expanding your mind. As we journey through time and space, from the first moments of existence to the formation of stars, galaxies, and life itself, let the vastness of the cosmos soothe your thoughts. Close your eyes, breathe deeply, and allow the wonders of the universe to guide you into peaceful rest. Imagine for a moment absolute nothingness. No space, no time, no stars, no planets, no energy, just pure emptiness. It's a concept that defies our understanding because everything we know exists inside time and space. And yet, somehow, out of this seeming nothingness, our universe was born. It gave rise to galaxies, stars, planets, and eventually us, creatures capable of looking back and asking, where did it all come from? Today, we take a journey through time itself, from the very first moment of existence to the grand cosmic structures we see today. A journey of chaos and creation, of destruction and rebirth. This is the story of everything. To understand the origin of the universe, we must go back to the very first instant of time, the Big Bang. Scientists believe that 13.8 billion years ago, all the energy, matter, and even the fabric of space itself were compressed into a single point, a singularity. This point was unimaginably small, far smaller than an atom, but contained everything that would ever exist. And then, in a moment that defies human comprehension, it exploded. But this was not an explosion in the way we think of one. There was no pre-existing space for it to expand into. Instead, space itself began to stretch and grow. This was the beginning of what scientists call cosmic inflation. In the first trillionth of a second, the universe expanded exponentially, far faster than the speed of light. What was once smaller than a subatomic particle now stretched to the size of a grapefruit. This sudden inflation set the stage for everything that would follow. As the universe expanded, it was unimaginably hot, trillions of degrees. Energy and matter existed in a formless, chaotic state. Subatomic particles popped in and out of existence, colliding, merging, and annihilating each other in a violent cosmic dance. The four fundamental forces that govern our reality, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, began to take shape. Then, as the universe cooled, quarks, the fundamental building blocks of matter, began to combine, forming protons and neutrons. But there was a problem. For every particle of matter created, an antimatter counterpart also emerged. And when matter and antimatter collide, they annihilate each other, leaving behind pure energy. So why is anything here at all? For reasons we still don't fully understand, there was a tiny imbalance. Just one extra particle of matter for every billion particles of antimatter. This small asymmetry meant that after most of the matter and antimatter annihilated each other, something remained. And that something became the building blocks of the universe. For the next 380,000 years, the universe remained a dense, hot plasma, a glowing, opaque fog where electrons roamed freely, preventing light from traveling far. But as the universe cooled further, something changed. Electrons slowed down enough to be captured by protons, forming the first stable atoms, mostly hydrogen and helium. For the first time in cosmic history, light could move freely through space. This moment, called recombination, allowed the first light of the universe to shine. This ancient light still exists today as the cosmic microwave background radiation, a faint glow that scientists can detect across the entire sky, carrying a snapshot of the universe as it was 13.8 billion years ago. But even though the universe was now transparent, it was still dark. No stars had formed yet, no galaxies, no planets, just a vast, silent expanse of hydrogen and helium gas. This was the cosmic dark ages. Gravity, the great sculptor of the cosmos, now took center stage. Over millions of years, tiny fluctuations in the density of the early universe allowed some regions to attract more matter than others. Slowly, under the relentless pull of gravity, vast clouds of hydrogen gas began to collapse. As these clouds grew denser, they heated up. And when the core of these forming stars reached 10 million degrees, a fundamental transformation occurred. Nuclear fusion ignited. The first stars were born. These first-generation stars, called Population 3 stars, were massive, hundreds of times the mass of our Sun, and burned at extreme temperatures. They lived fast and died young, exploding as supernovae after just a few million years. But in their fiery deaths, these stars created something new. They forged heavier elements like carbon, oxygen, iron, the raw materials from which planets, oceans, and life itself would one day be formed. As the first stars formed and exploded, they influenced their surroundings in profound ways. Their intense radiation ionized the surrounding hydrogen gas, ending the cosmic dark ages and ushering in a new phase of the universe's evolution, the epoch of reionization. This was a chaotic period. The young universe was filled with violent stellar winds, supernova explosions, and streams of ionized gas, constantly reshaped by the energetic radiation of the first stars. But as time passed, gravity continued its work. Small clusters of stars merged together, forming larger and more organized structures. These were the first protogalaxies, swirling clouds of stars and gas held together by gravity. Over hundreds of millions of years, these protogalaxies grew larger, merging with one another in a process of cosmic assembly. Each collision created larger and more complex structures, eventually leading to the formation of the first true galaxies. Galaxies came in many shapes and sizes. Some were massive spirals, with elegant arms spinning outward, much like our own Milky Way. Others were elliptical, featureless and smooth, filled with billions of ancient stars. And some were irregular, chaotic collections of gas and stars thrown together by the violent interactions of the early universe. But galaxies were not randomly scattered through space. Instead, they formed part of a larger cosmic web, a vast, intricate structure shaped by dark matter. Dark matter is an invisible form of mass that does not emit or absorb light, but its gravitational pull helped sculpt the grand structure of the cosmos. Over billions of years, dark matter collected into immense filaments, stretching across the universe like a spider's web. At the intersections of these filaments, galaxies formed in dense clusters, bound together by their mutual gravity. These clusters, in turn, became part of superclusters, the largest structures in the universe. Gigantic collections of galaxies stretching for hundreds of millions of light years. The Milky Way, our home, is part of one such supercluster, Laniakea, a vast cosmic region containing 100,000 galaxies. But as galaxies formed and stars continued to burn, something remarkable was happening in the quiet outskirts of a relatively ordinary galaxy. In a tiny, insignificant corner of the cosmos, the conditions were just right for something new, something that had never happened before in the history of the universe: the emergence of life. Our story begins in the swirling disk of gas and dust surrounding a young star, about 4.6 billion years ago. This star, our Sun, was one of countless billions formed in the wake of previous stellar explosions. But what made it special was the material left over after its birth: a rotating disk of dust, rock, ice, and metal. Over time, tiny grains of dust clumped together, forming pebbles. Pebbles became boulders. Boulders merged into planetesimals, which collided and grew into planets. In this chaotic, violent environment, Earth was born. At first, our planet was a molten hellscape, constantly bombarded by asteroids and comets. Volcanoes erupted across its surface, spewing gases into the sky. There were no oceans, no continents, only a churning, fiery wasteland. But something incredible was happening. Over millions of years, comets and asteroids delivered water to Earth, forming the first oceans. At the same time, the cooling of the planet allowed a thin atmosphere to form. And then, in the depths of these early oceans, something miraculous occurred. The exact details remain a mystery, but we know that, somehow, simple molecules arranged themselves into self-replicating structures. These structures became the first organic compounds, the raw ingredients for life. Over millions of years, these simple molecules evolved into primitive cells, the first living organisms. For billions of years, life remained microscopic, existing in the form of single-celled bacteria. These tiny organisms reshaped the planet, producing oxygen through photosynthesis and gradually transforming Earth's atmosphere. Then around 600 million years ago, something extraordinary happened. Life exploded in diversity. Multicellular organisms appeared, giving rise to an explosion of new forms. Fish, plants, insects, reptiles, mammals. The Earth, once barren and lifeless, became a world teeming with complexity. And then, just a few million years ago, on a small planet orbiting a mediocre star, one species emerged with the ability to question its own existence. We, humans, are made of the same elements forged in the hearts of dying stars. We are, quite literally, stardust that has come to life, capable of looking back at the universe that created us and asking, why are we here? As we look into the vastness of space, we see galaxies drifting farther and farther apart. The universe, which began as an infinitely small point, has expanded for 13.8 billion years, and it is still growing. But this raises a profound question. Will the universe expand forever? Will it slow down? Or will it one day collapse and start anew? Scientists have explored several possibilities, each leading to a dramatically different fate. Let's take a closer look. The Big Freeze, a cold, dark, and lonely universe. If the current trend continues, dark energy, the mysterious force accelerating the universe's expansion, will keep pushing galaxies apart at an ever-increasing rate. Over time, this expansion will lead to what is known as the Big Freeze, or heat death. At first, the universe would still look somewhat familiar. Galaxies would continue forming new stars as long as they have enough gas. But as billions of years pass, star formation will slow down. The vast reservoirs of gas that fuel stellar birth will be used up or dispersed. One by one, stars will burn out. Massive stars will explode in brilliant supernovae, but each explosion will leave behind a dead remnant, a neutron star, a white dwarf, or even a black hole. Smaller stars, like our sun, will simply fade away, cooling over trillions of years until they become cold, dark husks. As time stretches into unimaginable scales, hundreds of trillions, then quadrillions of years, black holes will dominate the universe. They will slowly consume the remaining matter, merging into even larger black holes. But even these titans are not eternal. Due to a process known as Hawking radiation, black holes slowly evaporate, losing energy over incomprehensibly long timescales. For a stellar mass black hole, this process takes 10 to the 64th years. For the largest black holes at the centers of galaxies, it could take 10 to the 100th years, a number so vast that it defies human comprehension. Eventually, every last black hole will vanish, leaving behind a universe that is completely dark. The only things remaining will be subatomic particles, drifting endlessly through an empty, frigid void. This is the Big Freeze, a universe where time still exists, but nothing happens. No new structures form, no stars shine, no warmth remains. The universe has reached its ultimate entropy. But could there be another fate? One where everything doesn't end in frozen emptiness, but rather collapses back into itself. The Big Crunch, a universe reborn. There is another possibility, one where expansion does not continue forever, but slows down, stops, and reverses. This is the idea behind the Big Crunch. For billions of years, the universe has been expanding. But what if the force of gravity, the fundamental attraction between all forms of matter, eventually overcomes dark energy? If that happens, the expansion of the universe would gradually slow down. Galaxies, instead of racing apart, would start moving toward each other. Over hundreds of billions of years, everything would begin collapsing inward. At first, the night sky might look much the same, but slowly, distant galaxies would appear larger as they approach. As time goes on, galaxies would merge in a cosmic catastrophe, forming enormous superclusters of stars. The cosmic microwave background, once a faint remnant of the early universe, would brighten as the universe heats up. As the collapse accelerates, temperatures would rise dramatically. Stars would be stripped from their galaxies and flung into the chaos. The very fabric of space would distort, crushed under its own gravity. Eventually, all matter and energy in the universe would be pulled together into an ever-shrinking space. The forces we understand would no longer behave normally. The laws of physics, as we know them, would break down. At the final moment, everything, the galaxies, the stars, the planets, even space and time itself, would be compressed into an infinitely dense singularity. And then, perhaps this singularity would ignite another Big Bang, a new universe, with new galaxies, new stars, and possibly even new life. If this is the case, then the universe is not a one-time event, but an endless cycle. Expansion, collapse, rebirth. A universe that dies, only to be born again. But there's one more, even more dramatic possibility. What if everything is torn apart before gravity ever gets a chance to act? The Big Rip, the ultimate cosmic catastrophe. There is still much we do not understand about dark energy, the mysterious force accelerating the expansion of the universe. What if it is not a constant force, but something that grows stronger over time? If dark energy becomes increasingly powerful, it could lead to the most violent end of all, the Big Rip. In this scenario, as the expansion of the universe accelerates, it does not slow down. It speeds up exponentially. At first, this would look much like the Big Freeze. Galaxies would continue to move apart, and the night sky would become increasingly empty. But unlike the Big Freeze, the acceleration wouldn't stop. Instead, it would reach a point where the very bonds holding matter together would be torn apart. First, galaxies themselves would be ripped apart as the force of expansion becomes greater than the gravitational forces holding them together. Then, individual solar systems would unravel, with planets drifting away from their stars. As expansion accelerates even further, the force of dark energy would become so strong that it would overpower atomic forces. Atoms would be torn apart. Nuclei would disintegrate. Even the very fabric of space-time would stretch and tear into oblivion. In the final moments, nothing remains. No galaxies, no stars, no atoms. Just an empty void expanding at an infinite rate. The laws of physics themselves would cease to function in any meaningful way. The universe would end not in cold emptiness or a fiery collapse, but in a violent, chaotic disintegration. So, which of these fates is our destiny? Right now, observations suggest that dark energy is pushing us toward a Big Freeze, an eternally expanding, ever-cooling universe. But we still do not fully understand the nature of dark energy. If it changes over time, it could lead to a big rip, or, if it weakens, even a big crunch. The fate of the universe depends on forces we are only beginning to comprehend. One day, perhaps billions of years from now, the answer will become clear. But for now, we are left with the greatest mystery of all. Why does the universe exist at all? Maybe in some distant future, an intelligent civilization, perhaps not unlike ours, will look into the night sky and finally uncover the truth. Until then, we can only wonder. The story of the universe is one of endless wonder, a tale written in the light of distant stars and the dust of ancient worlds. It is a story that continues to unfold in galaxies far beyond our sight and in the quiet corners of our own minds. As we close our journey through time and space tonight, let your thoughts drift among the stars, carried by the echoes of creation. Perhaps in your dreams, you will find yourself at the dawn of a new universe, witnessing the birth of everything once more.